Hello, in Unit 1 of this subsection, we will evaluate the carbon footprint of transport. The city shall report all greenhouse gases emissions from the combustion of fuels in transportation occurring within the city boundaries or the district or neighborhood, and it is the scope 1. The greenhouse gas emission from grid-supplied electricity used for transportation within the city boundaries is scope 2. Cities can also include greenhouse gas emissions associated with transboundary transportation. In this case, it will be scope 3. Most important transport modes, almost in all cities, are on-road transport, so cars, vehicles, and railway transportation. Waterborne and aviation transport modes can be important in some specific cases, but inside the city limits usually are not so important. It is important that when figures are obtained from Global Protocol for Community-Scaled Greenhouse Gas Inventories, it will be indicated in all this presentation as GPG source. The methodologies for estimating transport emissions can be broadly categorized as top-down or bottom-up. In top-down approach, start with the fuel consumption for a big unit, for example, for the whole city, and after that we have a downscaling factor to evaluate the emissions of transport in the district or the neighborhood or a part of the city. In the bottom-up approach, we start with very detailed data. So we really go to a method in which we need activity data, what we call the ASIF method. Activity, share, intensity, and fuel or electricity for determining the total emissions. The activity is usually measured as vehicle kilometer traveled, per kilometer per vehicle. The share, the mode share, the transport mode share indicates the portion of trips that are made by different modes, walking, biking, public transport, private car. And also it is important to separate between types of vehicles, motorcycle, car, bus, truck. Also we can separate between the different Euro standards of the emissions of cars according to the age of the vehicle. We need also an intensity of usually simplified as energy consumption per kilometer. This is the intensity of the transport we are evaluating. It is a function of the vehicle type and other characteristics or assumption. Finally, we need an emission factor associated to the consumed fuel or to the electricity in case of electric vehicle. In some cases, attending to fuel in the different vehicles for the different Euro standard, we use average in a mixed factor which is intensity and emission factor put together. In this case, we can obtain an E factor, intensity and emission factor, in kilograms of CO2 per kilometer. When we evaluate the public transport, we have to know information about the lines that pass inside the limits of the neighborhood, kilometers of the different lines, the frequency of daily travelers, and the emission per kilometer, the emission factor. In this case, for example, to calculate the greenhouse gas carbon footprint of one line, we need the distance, the kilometers, the frequency in travels per day, and the emission factor of the consumed fuel. This will be applied for metro, tram, or bus, for example. When we talk about the private transport, we evaluate really vehicles from the neighborhood, property of the inhabitants of the neighborhood, and also vehicles from outside the neighborhood, but that are passing through the limits of the neighborhood we are evaluating. And in some cases, this can be also depending on the work that performs on the team that performs the work. It can be considered as emissions of the neighborhood or not. It depends. It is, let's say, flexible. It depends on who does the work. In any case, we need the number of vehicles, the type, cars, two wheels, small trucks, the data of the vehicle, the type of fuel or the Euro standard or the year of matriculation, the kilometers that each vehicle is doing, and the emissions per kilometer and per type of vehicle. For example, when we talk about traffic in a general way, we need traffic composition, which is usually a vehicle inventory, which is available at national or regional statistics, how many vehicles of each Euro standard is in the vehicle inventory of the area. After that, we have to know the distance, and in some cases, in big cities, we have measurements of traffic. If we have the traffic, for example, the AADT, the annual average daily traffic, we can calculate the distance as this intensity indicator, the AADT, multiplied by the length of the road, because we are doing this road as many times as vehicles are present in the intensity factor. After that, we can evaluate for the whole year. So with this information, we can calculate the greenhouse gas emissions of this type of private transport in the neighborhood. As an alternative, it can be also used average distance per vehicle, but we have to estimate how much of this distance is done inside the limits of the neighborhood and how many vehicles of each type are present. The emission factors, for example, based on life cycle assessment, can be as the following values in the table. We are talking about older vehicles have higher emission factors, and electric vehicles or new vehicles that are more efficient have lower emission factors. In this case, these values come from life cycle assessment, so it's not only fuel combustion. It's also the life cycle of the vehicle and the refinement of the fuel, the transportation of the fuel until it arrives to the petrol station in the city, for example. If we want to evaluate only the emission of combustion, it can be used these emission factors for gasoline or petrol, for diesel, and for electricity. In this case, the emission factor of electricity is corresponding to Spain in year 2021.